difference between dividing and subtracting cosine and sine?
Can you give me the problem? So
Just a Pythagorean theorem.
so you're saying that sine squared alpha plus cosine squared alpha equals 1?
What is the difference between subtracting them?
Depending on what you're given. If I'm given this, then I have sine squared alpha equals 1 minus cosine squared to determine this. And then I'll take the square root. If I'm given this, then I will subtract it to get cosine squared.
But what about dividing? Is there any difference between?
Oh, we divided both sides by sine squared alpha to get a new identity. So we got 1 plus cotangent squared equals cosecant squared. Then the same identity, we divided both sides by cosine squared to get a new identity, which is tangent squared alpha plus 1 equals secant squared alpha. So from this equation, we determine these two equations. All three are very important. Of course, this is the initial one that led us to this and to this by simply manipulating, dividing both sides. But they're as important as that one is. You will not have this difficulty in this class because my department shows only examples in which sine and cosine are given. They did not choose any problem when tangent is given, or secant is given, or cotangent is given. So I'll stick with their rule, because the rest of the problems should be presented in 142. So I didn't see any problem that requested us or was giving us cotangent, secant, or tangent. These are in 5.3, correct? Yeah, they only chose cosine and sine is given. They didn't choose anything else. So for example, they did not choose 29, where tangent is given, or 33, which is secant is given, or tangent, or so on and so forth. So now for us, this is the most important one. These are somewhat less important because, good, very good question. Anything else? Is there anything else that you worked on that you would like to look at?
24 page.
Very good. 24 page 516. 560. Thank you. 24. Okay. So what was the problem with this? Is it a homework problem?
No, it's just.
Okay. So was there a difficulty with it or?
Yeah.
Very good. Let's do it together. So the quadrant, theta is in a third quadrant. Good. Then the problem was asking us to find exact values of all the other 5 trig functions. So I'm asked to find cosine, I'm asked to find tangent, cotangent, secant, and cosecant. In the third quadrant, sine is negative. Can anyone give us the sign of cosine in the third quadrant? Remember, cosine is measured on the x-axis? Negative. Very good. So they are both negative, then I know the sign of tangent. I don't even have to think where it is. Good. I know the sign of cotangent. I don't even need to know where it is because I have sine and cosine which are negative. Good. Secant is 1 over? Good. So it's this one. So what is the sign? Good. And finally, cosecant is right, because it's 1 over sine, so it's negative. So I established the signs. I don't have to think about them anymore. I'm given sine. How do I determine cosine? Because once I get cosine, I'm done. How do I get cosine? Right. Right? So cosine squared equals 1 minus sine squared with a square root. So then cosine theta equals plus or minus the square root of 1 minus sine theta, sine squared theta. Because I know it's minus, I will say no, just minus. Because it cannot be in, cosine in a quadrant cannot be positive or negative. Can only be, in this case, negative. So then I will plug in 12 over 13 and square it and perform this operation. So let's see what we get when we do that. Very good question. It's a good warm-up question. So then cosine theta equals negative the square root of 1 minus, when I square a negative number, I get a positive number, 144 over 169. I find that the least common denominator is, very good, 169. So this needs a 169, and 169 minus 144 is 25. Very good. And when I take the square root from the top, I get, and when I get the square, take the square root from the bottom, and I'm done. Because now I know that this is 5 over 13, and I know the rest of them. Why? Because I know tangent is this ratio, cotangent is this ratio, secant is 1 over cosine, and cosecant is 1 over sine. Can anyone give us the rest of 4 trig functions? Very good. 12 over 5. Cotangent. Right. 5 over 12. Secant. Right, because it's this one, right? So it's 13, the multiplicative inverse. And cosecant is? So once you have sine and cosine, the other 4 will follow with no calculations. You don't have to think. But I did set the signs from the beginning because I needed to know. Although you can say, do I really need to do this? Once I have cosine, the signs will follow. That's fine too. So once you find cosine and you see that they are both negative, when you divide, you'll get a positive number. When you flip that, you'll still have positive, and so on and so forth. Very good question. Anything else? Anything else? Okay, I would like to continue with the graphs. Let's look at graphs of sine and cosine functions. That's section 5.5. And just the graphs of the other trig functions, but my department said only tangent. So I'm going to stick with tangent. So in the next 2 sections, 5.5 and 5.6, we are going to look at 3 functions. They're graphs. So section 5.5 and 5.6 together, the graphs of sine x, cosine x, and tangent x. And of course, there is no escape from little transformations, just a little bit, because we know them and we studied them. Okay, so let's start with f of x, which is sine x. Let's look at the unit circle for a moment. And if you remember, I said we have to memorize. I don't like to say that, but sometimes I have to. We have to memorize this little chart. Pi over 6, which is 30 degrees, pi over 4, which is 45, and pi over 3. And just sine and cosine. These are only 3 numbers that I'm kindly asking you to remember. So, always the little chart, you can always graph it. Put it in your, when I give you the test paper or the final exam paper, just write it down on scratch paper. I'm fine with that. So, can anyone give us this number? Right. So, always the little chart starts with 1/2. And it jumps here as well. Correct. And then this one is the other number. Good, which is here. And these two are the only angle that has these two the same. In addition to this, I have no choice but to memorize, which I don't have to memorize, right? Because I already know them from all this experience with math. I know the coordinates of this, 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 and this point. So this point. Right. This point. Right. This point. And this point. Excellent. So now, I'm going to ask you, remember cosine is measured because it's the adjacent, and sine is measured here because it's the opposite. So if I ask you sine, and you don't have to edit here, you just have to think in terms of this little unit circle. If I ask you, for example, cosine pi, what will you say? It's measured on the x-axis, -1. If I say sine 3 pi over 2 is measured on the y-axis, -1. It's right here. This is the 3 pi over 2. 1, 2, 3 pi over 2. Now, if I ask sine 0, right, it's measured on the y-axis. This is always cosine. This is always cosine. This is always cosine because it's measured on the x-axis. And this is always sine because it's measured on the y-axis. And now, two other things. Basically one. What is the maximum possible value of any angle sine? Sine of whatever you want. What is the maximum possible? Say it again. No. I cannot say that that sine of an angle is another angle. I'm saying sine of any angle you want, maximum is how much? 1. 1. No matter where I go around this unit circle, this is the maximum possible number as a result of any sine, of any angle. Right? So then I will say that sine, any angle, cannot be more than 1. What is the minimum possible sine for any angle you can think of? Of course. It's right here. Everything else is in between. So sine maximum is 1, sine minimum is -1. This is called, it's a bounded function. So if somebody on a test says this, how many points should I give? None. Right? I cannot see sine of blah being 3. Sine of blah can be maximum and can be minimum. Excellent. What can you say about cosine now? What is the maximum possible value that you can ever find for any angle cosine? What is the minimum possible value for any cosine? Right, because it's measured here. It's between this number and this number. It cannot be less than -1, and it cannot be more than 1. So if I ask cosine of 75 degrees, will you say -3? You cannot say -3. You can say anything between -1 and 1. Is that clear? This doesn't happen with the other functions, though. These are the only trig functions that are bounded. Max 1, min -1. But now, let's say, and then we'll get to the graphs in a minute. What if I have the function f of x equals 3 sine x? What is now the maximum possible value of this function? Yes, because sine cannot be more than 1. But 1 has to be multiplied by 3. What is the smallest possible value of this function that we can have? -3, because this can be -1 times 3, it's -3. This function is bounded. 3 sine x is bounded between -1 and 1. I'm sorry, I meant to say -3 and 3. All I have to do is just multiply this, both sides by 3. All 3 sides by 3. So this can happen, but plain sine cannot be more than 1, and it cannot be less than -1. Okay, so now I'm ready to graph this function. Now, actually, one more thing. Period. Trig functions, all 6, are periodic functions. 4 of them have the same period. These 4 have period 2 pi, and they are sine x, cosine x, secant x, I'm sorry, yes, and cosecant x. The other two have period pi, and they are tangent x and cotangent x. What does this mean? Here's what it means. If I graph sine, cosine, secant, cosecant between 0 and 2 pi, I have the entire graph, because this graph repeats itself from 2 pi to 4 pi, repeats itself between negative 2 pi and 0, repeats itself between negative 4 pi and negative 2 pi. That's what it means. Tangent and cotangent, they repeat themselves between 0 and pi. Actually, one of them between negative pi and pi, negative pi over 2 and pi over 2, but we'll talk about it in a minute. But between 0 and pi, I have everything. Between pi and 2 pi, I have everything. Between 2 pi and 3 pi, I have everything. That's all it means. Okay. So therefore, when we graph sine, we will graph it between 0 and 2 pi. When we graph cosine, we'll graph it between 0 and 2 pi. When we graph tangent, it's a little bit different, but we will graph a period of pi. Okay, so let's start with plain sine. And I need at least these for now. Okay. So f of x equals sine x. Pi over 2, pi, 3 pi over 2, and 2 pi. 90, 180, 270, and 360. So let's go around the unit circle. Maybe I should keep this here. And I'm going to ask you sine of 0. Sine of 0 is
0.
Very good, right here. Sine pi over 2. Right. Cosine is the first one. Cosine is measured on the x-axis. The second coordinate or y-coordinate is the y-axis, which is sine. Sine pi. Sine 3 pi over 2. Sine 2 pi. Here's the graph. So let's do this with the graphing calculator. Okay, in y equals, clear if you have anything else. Just punch in sine, x, close the parenthesis. I recommend go to mode and make it in radians. Make sure it's in radians. Scroll down to radian mode and press enter. Now let's go to window. I want to show, we can show more, but I want to show for now from 0 to 2 pi. Here's your pi right here where the caret is. So between 0 and 2 pi. The scale of pi over 2. So pi divided by 2. How high do I want to be? Because I know, yes, but I'm going to go to 2 so it doesn't hit the top of the viewing window. So I'm going to say between -2 and 2 with a scale of 1. And now I'm ready to graph. I should see just one complete graph between 0 and 2 pi. It's period. Here it is. Here's a question for you. What if I want to graph now f of x equals sine x minus pi over 2? What type of transformation is this? Where will the graph go? It will shift.
Horizontal shift
Where? Which direction?
to the right.
To the right, how much?
by
So where does this point go? Let me use a different color. I'm sorry, I wanted to. I'm looking for the green. Okay, very good. Where will this point go? And so on and so forth. So this is the graph of this function. Sine x minus pi over 2. What if now I would like to graph f of x, which is 2 sine x minus pi over 2. What transformation will this be? So we go into, so let me explain here. Pi over 2 is called phase shift. It was called just shift before with the other functions. For trig functions, it's called phase shift. The period stays the same, but now the interval on which I will graph this function will be between pi over 2 and 2 pi plus pi over 2, which is 5 pi over 2, right? So the window will change. Yes, it will continue forever on both sides. So I just wanted to see one. But if you go back to your graphing calculator, and now for this function, for example, you change the viewing window between negative 10 and, let me just put standard, okay, 6. Then you will see more than just that. I see different. So this is one period. This is another period. And so on and so forth. It goes on forever. Okay, now, one more time, what was the maximum for this function? Maximum possible value for this function. 1. What is the minimum possible value? So that happens because this number in front is 1. So the amplitude is the absolute value of the number in front, which is 1. What does the amplitude mean? How high it goes and how low it goes. It goes up to 1 and lower to negative 1. Can anyone now tell us the amplitude? So A is the amplitude. What is the amplitude for this? 2. It's the absolute value because it can't be negative. So it's the absolute value of 2, which is 2, which means how high can it go? How low can it go? Right. So let's graph this one. So in y equals, I have 2 in front and minus pi divided by 2. And graph. See, it no longer stops at 1 and negative 1, and it has a shift. So now this is the complete period. From positive pi over 2 to 5 pi over 2. But it goes up to 2 and low to 2, negative 2. Only sine and cosine have amplitude. Tangent, secant, tangent, cotangent, secant, cosecant do not have amplitude. So let me write this down. Only sine and cosine have amplitude. Oops, sorry. Only sine and cosine have amplitude. The other 4 functions, trig functions, do not. Okay, here's another example. What if I want to graph f of x, which is sine twice x? What kind of transformation is this? I'm changing x or I'm changing y? I'm changing x. What type of transformation I'm getting into when I change x into twice x? This is the only one that I said, gee, I cannot really see it. is the only one that is not straightforward. So when I change x into 2x, do I do this or do I do this? It's the second one. It's the only one that does not make sense, if you want. So the period of this function is 2 pi divided by the number that multiplies x. Notice that this is not the same thing. This is the number that multiplies x for the period, 1. And this is the number that will give us the amplitude, which is the number outside of sine. Can anyone give us the period for this function, which is 2 pi? Can anyone give us the period for this function? It is 2 pi divided by the number that multiplies x. So what number multiplies x? 2. So the answer is 1 pi or pi. So the normal period is this, but when I change x into 2x, what do I do with the period? It's the only one that we, in chapter 3, in chapter 2, we said this is the only one that doesn't seem right, but that's the case. So let's look at the graphing calculator. So I want to go back now to, y. And in order to illustrate this, I will put both functions on the same. I'm going to change this. Let me do this. Sine x. And here is sine. One thing, at least one thing, maybe more, about this program I like is because it will show two graphs in two different colors. I really like that. So because it's very clear now, as you see, y2 will appear in red and y1 will appear in blue. But now I want to change the viewing window back to the original viewing window, which is 0 to 2 pi. And with a scale of pi over 2. And because it goes to 2 and negative, no, we don't, I erased the 2 in front. So from negative 2 to 2 is good enough with a scale of 1. And now I graph. Here comes the graph of the plane sine. And look at this one. From a period of 0 to 2 pi, look at this one. Of course, I will see two complete periods because the period is only between 0 and pi. This is sine twice x. This blue is sine x between 0 and 2 pi. But this is a complete period between 0 and pi. Why? Because when I changed x into 2x from 0 to 2 pi, it's a horizontal shrinking of the graph by a factor of 2. That's why I have two of those in one period for the blue function. I wish I could have shown you this in chapter 2, but I couldn't because we didn't have this function then to see what happens with that 2. What do you think will happen if I add in here sine 1/2 x? Sine 0.5x. What will be the period? 2 pi divided by 1/2, it will be 4. So it will be a horizontal stretching from 0 to 2 pi to 0 to 4 pi. So I have to change the viewing window because otherwise I will not see the black function, complete period. So I'll go back and I will just change the maximum into 4 pi. And now I will graph all of them. Here comes the original function. Of course, now I have two original functions into 0 to 4 pi. I will have 4. 1, 2, 3, 4 of the second function, which is a horizontal shrinking. And I will have 1, just 1, of sine 1/2 x. Because its period is 4 pi. Again, I wish I had this in chapter 2, but I couldn't use it as a function. So now we know twice x is this, and 1/2 x is this. This is by a factor of 1/2, and this is by a factor of 2. Of course, I can change 2 into 3, and so on and so forth, and will happen. The period would be 6 pi, and so on and so forth. Okay, I think we haven't had enough of this, so let's look at cosine now. So f of x equals cosine x. The period is 2 pi. Of course, the amplitude is 1, or the absolute value of 1. So we are going to look at 0, pi over 2, pi, 3 pi over 2, and 2 pi. How much is cosine? And it cannot be more than, if I ask cosine of 100 degrees, how much will you say maximum possible? 1. And cosine of blah, what is the minimum possible? So let's go back to our unit circle. Cosine 0 is measured on the x-axis. Cosine 0 is 1. Cosine pi over 2 is measured on the x-axis, 0. Cosine pi is measured on the x-axis. Here's pi, -1. Cosine 3 pi over 2 is measured on the x-axis. And finally, cosine 2 pi ready? Of course, it continues forever. If I want to graph y equals cosine 1/3 x, I only want the period from you, which is 2 pi divided by the number in front of x. What number I see in front of x? 1/3. What will this period be? 6 pi. So 1/3 in front of x does this. Okay. What about y equals -4 cosine x? I just want the amplitude. What is the maximum possible value for this function? What is the minimum possible value for this function? So it's the -4 in front in absolute value, which is 4. Let's look at tangent. And then we'll look at problems from the book. This is the last trig function we will look at, graph-wise. So f of x, tangent x. Well, tangent x is not a friendly function because it's a ratio of 2 functions, and it can be undefined when cosine is 0. So there is a problem here. So we know from chapter 3 that when a rational function is undefined, at that point, and it cannot be simplified in any way, at that point the function has a vertical asymptote. So this is a function with problems. So vertical asymptote when cosine x is 0. So this function has infinitely many vertical asymptotes. Anytime cosine is 0 for a particular value, like here, like here, like here, like here, like here, and so on and so forth, all these will turn into vertical asymptotes for the tangent. So at -π/2, at π/2, at 3π/2, at 2 pi plus π/2, which is 5π/2, and so on and so forth, all these are vertical asymptotes for the tangent. So because the period for tangent and cotangent is pi, so period for tangent is pi, we will graph it between -π/2 and pi over 2. Of course, it will go on forever, and I'll show you examples. So this is negative pi over 2 and pi over 2, because here cosine pi over 2 is 0. And because here cosine negative pi over 2 is 0, which makes tangent to be undefined. And this will remind you of a function that we studied a lot in chapter 3. It's not, of course, it's not that function, because that function does not have asymptotes. But it's very similar looking. So this is f of x, tangent x. Can anyone remind us which function, or tell us which function it resembles? It's not, right? X cubed, indeed. But you know that that is a polynomial function and it has no asymptotes. But something to trigger our memory. When we talk about tangent, oh, I remember it's something similar to x cubed. But it's not x cubed. X cubed is a polynomial defined everywhere, no asymptotes. Okay, so let's graph this. Let's say this time we want to graph more than one period. For whatever reason. I'm going to say between negative 2 pi. Oh, I'm sorry, I didn't mean that. I meant to write tangent first and x, of course. And then go to the viewing window, and let's say this time between negative, oh, we already see it here. But let's say we want between negative 2 pi and 2 pi, and with a scale of, and of course, not negative 2 to 2 because it goes on forever. I'm going to say negative, I don't know, 8 to 8. And press enter. See, my calculator does not show the vertical asymptotes. But if I show you with this, it will appear. And again, I don't know how to make them show. I didn't investigate. I forgot. I should have investigated how to put the vertical asymptotes. Okay, so this is tangent. 0. So this is pi over 2. This is x equals negative pi over 2, and so on and so forth, and it goes on forever. Okay, let's look at on page 589. Let's look at a few examples. Determine the amplitude of each function, then graph the function. I'm happy if you just determine the amplitude. So let's look at problem 6 on page 589. Y equals negative 4 sine x. We just talked about something similar. So can anyone give us the amplitude, which has to be the absolute value of negative 4, which is 4. So this function, when you graph it, its maximum value will be 4, its minimum value will be negative 4. Okay, determine the amplitude and the period now. So the next question is asking us to determine the amplitude and the period. And I'm going, oh, I'm sorry, forgive me. Sorry about that. So this was 6 on page 589. So y equals negative 4 sine x. The amplitude is the absolute value of negative 4, which is 4. Okay, let's look at problem 14 on the same page, 589. So I have y equals negative 2 sine pi x. I'm asked to determine this time two things. I'm asked to determine the amplitude and the period. Can anyone give us the amplitude for this function? It's the absolute value of 2, which is 2 indeed. Since we're talking about sine, this must be 2 pi divided by, and I'm going to write it here, yes, the number in front of x. So then I simplify pi with pi, and for this function, the period will be exactly 2. Very good.
I have a question.
Yes, please.
For the test, and when you ask for the amplitude, if we say 2, that's okay, or do you want?
That's okay. That's okay. But if you write this and you make a mistake, then at least I know you know that it has to be the absolute value. I recommend write the absolute value first. Very good question. Problem 20. Yes, please.
Just to be clear,
Yes.
for the period, it's 2 pi divided by the number in front of it.
Yes. And the number in front of x is pi.
Okay.
So since I'm dividing by pi, I can simplify and I get 2.
I just want to make sure.
Right. So problem, anything else? Okay, problem 20. Let me break the video in the middle.